evaluating problems with trying to, I want to just approach it leaving it as radians, because you do end up eventually with the question that you're having where maybe your argument is no longer a convenient value of radians. So we don't deal with point or 1.2 radians or pi radians very often. We're usually looking at, if you broke it down, we're usually looking at multiples of 30, which would be multiples of pi over 6. So 30 degrees is the same thing as pi over 6. 45 degrees is the same thing as pi over 4. So really what we're doing is we're looking at multiples of those things. So if I multiply 30 by 2, then I have to multiply the right-hand side of pi over 6 by 2, right? And that can be 2 pi over 6, but 2 pi over 6 is pi over 3 reduced, right? So we see that 60 degrees is the same thing as pi over 3. 45 degrees, if I double that, I get 90. So double pi over 4, you get 2 pi over 4, which we reduce to pi over 2. So as we start learning these things and dealing with them more often, you're usually going to see denominators that are 6s, 3s, and 4s. Every once in a while, you'll see a 12 thrown up there. And then when we get better at this, we start getting into other chapters, then it's kind of fair game of what that denominator wants to be. But what I like to do is realize that we're just talking about thinking about one complete circle here. Okay, so we know in a circle, if I start at 0 radians and go all the way around, what are you going to get back to? 2 pi radians, right? Those are the coterminal angles. And if we did it in degrees, that's 0 degrees and 360 degrees, right? Okay. Now, if I only went halfway around, I would have gotten 2 pi radians, right? Okay. Now, because this is a 6 on the bottom, okay, and actually, let's do it this way. Let's do, because negative 11 pi over 6 is, we'll come back and do it, but let's initially do this question. Let's do cosine of negative 7 pi over 6. Let's do that one first. But it's hard. It's really hard to compare where 7 pi over 6 is going to be in regards to 2 pi and pi, because these denominators are as 1s right now, right? So when comparing 7 pi over 6 and 2 pi over 1, that's hard to do because the denominators are different. For instance, if I had an equation, if I wanted to say, okay, let's not even an equation, let's say I had 2/3 and 1/3. Which one is bigger? 2/3, right? Because the 2 is bigger than the 1, right? When the denominators are equal, we can just compare the numerators. So, even if I had like 2/3 and 2/6, it's still 2/3 and 1/3, right? But can I compare that way? Can I just look at the numerators and say that they're different? Does that kind of make sense to everybody? So when I want to compare and look at where these angles are, the best thing to do is to look at that denominator of 6. And we call that the argument, the thing in the parentheses, the angle measurement. And write in our picture these key values in terms of that denominator. So I'm going to write this as, what would it be? If it's a 6 on the bottom, it's got to be, 12 pi over 6? Is that okay with everybody? And this thing here would be 6 pi over 6. You can, we know this is going to be, we've called it pi over 2 a lot. Okay. Think about, if it was, because that's 90 degrees, right? Would you guys agree that that's 90 degrees? And if I double this, 45 degrees, that's 90. So I got to double this. So it can be pi over 2 eventually when I reduce. But in regards to a denominator of 6, wouldn't you agree that that's 3 pi over 6? Okay. And this one here would be, normally it's 3 pi over 2. Okay, so, maybe developing some associations here. 90 degrees is pi over 2. 270 degrees, which would be that angle right there, that is 3 pi over 2. Because it's that 90 degrees plus that 90 degrees plus that 90 degrees, right? So pi over 2 plus pi over 2 plus pi over 2 gives you 3 pi is over 2, right? But writing it with a denominator of 12, or sorry, 6, would be 9 pi over 6, right? Okay. Now, and let's actually do it this. I said I wanted to do this one, which we will. Let's do this one first. Let's do positive 7 pi over 6. See how we can address that one. Cosine of 7 pi over 6. So what we do, the 7 pi over 6 is positive now, if we're going to do that problem. So now the theta angle that we're looking at, obviously we know that theta's got to go past there, right? Because that's not 7 pi over 6 yet. It's got to go past there because that's not 7 pi over 6 yet, right? Where is that theta going to end? Is it going to end in this quadrant, or is it going to go into this one? It's got to end in this quadrant here, right? Because if it goes past this line right here, we're saying that the angle's got to be bigger than 9 pi over 6. Well, 7 pi over 6 is not bigger than that, right? So we stop there in that quadrant. I'm not sure exactly where to put that right now, especially maybe the first couple times we're doing these. But that angle that we just traced out, that theta, is 7 pi over 6 radians. Okay? Now, the angle that we're interested in, or that we're going to use here, that angle right there, which we're calling theta bar, right? That's our reference angle. How big would that reference angle be, that little red angle, if the black ray is defining the angle of 7 pi over 6, and the x-axis is defining 6 pi over 6? It'd be pi over 6, right? Does that make sense, everyone? Okay. I always visualize or think about, okay, if this is where my terminal ray stops, how much do I have to rotate it back up to get to the x-axis? Well, if I went 7 pi over 6, that was pi over 6 too far, or pi over 6 radians beyond the x-axis. So then that's the pi over 6 that I need to go back to become the x-axis. So my theta bar is pi over 6. Okay. Now, reference angles. I maybe show you this picture. Just it might be a cleaner way of doing this for some of us. The reason we call that a reference angle is because it's going to tell us everything we need to know about 7 pi over 6, right? Okay. So theta bar is going to tell you everything you need to know about theta. Most people maybe are comfortable with that pi over 6 in the first quadrant and drawing that triangle in the first quadrant. Okay. Now, if it's pi over 6, we said pi over 6 was how many degrees? 30. Okay. So you're always going to have that relationship in your mind. A 30-degree angle here would give me this side here to be n, wouldn't it? It would give me this side to be 2n and this side to be n radical 3. So everything that I can learn about that red triangle is going to be the exact same thing about that green angle theta of 7 pi over 6. Okay? Except for the plus or minus component. Okay? So really, in answering the problem, guys, the entire problem is going to be answered with this picture here. The plus or minus is going to be answered with this picture up here. Okay. So when I want to know cosine of pi over 6 is equal to adjacent divided by hypotenuse, right? So let's go n root 3 over 2n. What's going to happen with your n's? Cancel out, so I get root 3 over 2. So cosine of pi over 6 is root 3 over 2. Therefore, the cosine of 7 pi over 6 is the exact same thing. The cosine of the reference angle is exactly the same thing as the cosine of the original angle, except for the plus or minus that goes out front. If I look at the original picture we drew, the cosine of 7 pi over 6 stops in what quadrant? Third quadrant. And cosine in the third quadrant is what kind of number? Negative. Okay. Now, the reason we do it that way, or we can view it that way, is because if I were to just draw the triangle in this quadrant, just dealing with that triangle right there, right? That red angle being essentially a 30-degree angle, this would be in, but now it's what direction? It's down, right? So it'd be negative. So your y value would be, to get to that point right there, your y value would be negative, right? This distance here is from 0, 0 goes to the left, so that is negative as well. And our hypotenuse, your hypotenuse is always found by squaring that, adding it to the square of that, so your hypotenuse is always going to be positive. But now if I did adjacent, which is that number there, divided by hypotenuse, which is that number there, will give me the exact same thing this gives me in addition with the sign. Does that make sense? And it doesn't eventually get me that answer right there. But some people like to pull that reference angle out and put it in its own picture, deal with that 30, 60, 90 triangle all on its own, and then just realize, it was a third quadrant, so it's got to be negative. Or a fourth quadrant, it's got to be positive, something like that. Does that kind of make sense? Okay. So let's do this thing with negative 7 pi over 6. So negative 7 pi over 6. I'll use the exact same set of axes. Still the same denominator, so I'm going to write this as, your 2 pi is the same thing as 12 pi over 6. This is 6 pi over 6, 9 pi over 6, and 3 pi over 6. But if I'm doing cosine of negative 7 pi over 6, negative tells me what? If I'm looking at a negative angle measurement, it tells me, guys remember? Yes, that's all it does. It tells me the direction that the angle needs to be traced out. It tells me now to go clockwise. So I'm going to trace out this angle. Now, here's the thing. That angle right there that I've traced out, is it 9 pi over 6 radians? No. It's negative 3 pi over 6 radians, right? I've only traced out 90 degrees in that direction. So you got to kind of flip these things and think about them that way. Okay. But if I go this way, I have traced out 180 degrees, right? I have traced out 6 pi over 6 radians just in the negative direction, correct? Okay. So if I want to put a negative sign there with that, I could. But now how far do I need to go beyond that? Will I go past this line right here? No. Okay, I'm going to stop in that quadrant, and that's going to be my terminal array. Now this angle theta that we're interested in is negative 7 pi over 6. So now, how many degrees do I need to go, or how many radians do I need to go back to figure out what my theta bar is? Pi over 6. So theta bar is pi over 6 radians. So now think about this. Insert that thing back into the first quadrant. If this is pi over 6, that's 30 degrees again. So this is n, 2n, and n root 3, right? If I want the cosine of pi over 6, that's going to be n root 3 over 2n, which just gives me root 3 over 2, right? So everything that I learned about that angle right there, of pi over 6, tells me exact same thing I need to learn about this angle right here of negative 7 pi over 6. Except for, where does the cosine, or what value is the cosine in quadrant 2? Okay, if cosine would be negative, right? Because if we go back and look at this triangle here, cosine is adjacent divided by hypotenuse, right? It's a negative distance now in the second quadrant divided by a positive. So cosine of negative 7 pi over 6 is equal to negative root 3 over 2. Okay? Some of you might not like that. Okay? You might not like dealing with negative angles, and that's 100% perfectly fine. A lot of people don't like working with negative angles. Can we work with a positive angle here? Can I do enough work? Because we know that whatever angle you start with, you can either make it negative or positive by adding multiples of 2 pi, couldn't you? So let's say that I've got this negative 7 pi over 6, negative 7 pi over 6, and I want to deal with it. They're asking the cosine of it, but I don't like that. Really hate negative angles, so let's do this. Negative 7 pi over 6 plus 2 pi in this version. Would that give me, it's going to be negative, would that give me cosine of 5 pi over 6? Does that make sense? Okay? So now drawing my picture, if this is 12 pi over 6 and this is 6 pi over 6, I don't quite get to 6 pi over 6, right? I got to stop short. I got to stop at 5 pi over 6. That's terrible. So maybe my ray is right there. So that's theta. What would theta bar be here to get to there? It'd be pi over 6 again, right? Do you see that picture right there is exactly the same result as that picture right there? It's just we viewed it going counterclockwise instead of clockwise. But what I learned, the idea here is what I learned about 5 pi over 6, when I get that solution, that exact value of negative radical 3 over 2, that is the exact same thing as negative 7 pi over 6 because of the coterminal. All right? So if you want to, you can always do that. Whenever they give you a negative angle, if you want to always add multiples of 2 pi or 360 degrees, depending on the mode that you're in, to get a positive angle, you can do that. All right? And if you're a person who consistently says, oh, I dread these negative angle questions, because I always get them wrong. Well, now you have a route or a technique to never, ever, ever have a negative angle question, right? Okay. Now, if we did the, I guess the original one, do we need to do the cosine of negative 11 pi over 6? You want to do that one? If we did negative 11 pi over 6, just real quick, using that approach, cosine of negative 11 pi over 6 plus 12 pi over 6 would give me what? Yeah, cosine of pi over 6. So now, this angle here, that would be negative 11 pi over 6. Okay? Well, it makes it a little bit easier if I just view it as a positive angle, and I deal with that triangle in the first quadrant. And you'll find out that that's radical 3 over 2. Okay? Now, when you get to questions like this, and this is just asking reference angles, okay, you want to do the same thing. If I've got my axes here, and right now my denominator is 5, right? So this is 2 pi over 1, so I'm going to rewrite that as 10 pi over 5, right? So this would be 5 pi over 5. And this thing here, now it's really not convenient, but it would be, half of this number here, right? So it'd be 2.5 pi over 5. That still reduces to pi over 2, doesn't it? If you run it right as 5 halves pi over 5, you can do that. It's just uglier. So now if I want 3 pi over 5, would you agree that 3, that numerator, is going to be into this quadrant here? I'm going to be tracing an angle out that goes past. That's 2.5 pi. So 3 pi would be about right there, right? Does that make sense, everyone? So that would be the theta that I'm tracing out. So theta bar is going to be that angle there. Well, if this red ray is going through 3 pi over 5, how many ratings do I need to get to 5 pi over 5? 2 pi over 5. Okay? And this is where this comes into play. And we could do this as a positive version or a negative version, doesn't matter. If we do it as a negative version, right now it's just in regards to our rational numbers. So let's just say that this is 2 pi. This would be 1 pi, right? Okay. This is pi over 2, or 0.5 pi. And this is 1.5 pi, or 3 over 2. Does that make sense? So now it's negative, so I'm going in this direction. I'm going to go, there's 1 pi, negative 1 pi, right? And then I need to go a little bit further to get to negative, theta here is negative 1.2 pi. So what would be that theta bar that I need to get back down to 1 pi? It'd be this 0.2 pi. Okay. If you're a person that says, I don't like the negatives, well, add 2 pi to that. What's that give me? 0.8 pi, right? So could I look at it as going 0.8 pi if this is 2 pi and this is 1 pi? Go 0.8 does it terminate in the exact same spot? Yeah. Okay. 1.2 pi. Oh, sorry. Okay. Here's where this gets kind of ugly and confusing for people. There is no pi with that one, right? All right. So this is how we deal with this. If I go, basically what we're saying is that the pi has already been multiplied through this number. Okay. What we're looking at here is that this is 0. This is 2 pi, right? Or approximately 6.28. This is pi, or approximately 3.14. This is pi over 2, or approximately 1.57, right? Okay. And this one's 5 something, I think. So basically just turning those key markers on our axes to the decimal approximation, 4.7. Okay, so those are numbers that pi has already been multiplied through, and we receive those decimals back, right? So would you agree that 1.2 is kind of an angle right there? If I would say like 2.5. If I wanted to know the reference angle 2.5, then I'm going to go, there's 1.5. I'm going to go into this range, or this quadrant. I'm going to stop because I know I'm not going to get to 3.14, right? So how would I then determine that there? What two numbers would I subtract? Yeah, 3.14 minus 2.5, and that's going to give me my, 0.64 that I need. All right. Those questions, I think, force you to pay attention to detail because you start, and it's an issue with how they present question A and question B, because they got that pi in there, right? And people see question C and just start doing it as if pi was still there, right? So if you're missing those questions, maybe that's something to think about as you're doing them. We're gonna see a lot of these guys, and I want to make sure that we get enough information here covered today so that you guys can get through the bulk of the remaining questions on 5.3. But let's talk about these here. These were the end of yesterday's assignment. And they're just asking you essentially a way of determining where your angle ends. Okay? If theta is greater than 0, if sine of theta is greater than 0, that's a way for them to say mathematically that they're asking for sine of theta to be positive. Okay? So they're asking, what quadrant does sine of theta end up being positive? Well, we know sine, if I write all students take calculus here, we know sine is positive in this quadrant and it's positive in that quadrant, don't we? Okay? But at the same time, cosine needs to be what kind of number? Negative. Cosine is negative in that quadrant and that quadrant, right? Well, which quadrant has both properties? Because the word and here, quadrant 2 has both those, right? So our theta, that whatever theta is here, is going to lie in that quadrant. Okay. If we do the same thing with tangent, tangent of theta is negative. Okay. So tangent is negative in this quadrant and this quadrant, right? Okay. Remember, these letters are for the things that are positive in those quadrants. Okay. And then this says sine is what kind of number? Positive. Sine is positive in that quadrant and that quadrant, right? So we're looking again at quadrant 2 because that's where the kind of the overlap is. Okay. So one of these pieces of information is going to narrow your view down to 2 quadrants, okay, out of the 4. And then the other one is going to narrow yourself down out of those 2 quadrants down to 1 quadrant. Does that make sense? Okay. Now I want to talk about this because it's important for how we're going to see other questions written throughout the course. They're going to ask us to deal with an unknown theta and give us some relationships. And they might say, now theta is the sine of theta is less than 0. Well, that tells me then that I've got to be looking at a negative value, so theta is going to reside in the third or fourth quadrant for sine, right? Okay. So those are things that we want to pay attention to because they're gonna help us essentially get the correct plus or minus sign for our answer later on. I want to do one of these at the bottom. So this bottom one, I don't deal with cosecant and secant and cotangent all that well, but I know that whatever their sign is, their reciprocal function has the exact same sign, right? SIGN. So instead of dealing with cosecant being less than 0, I'm going to ask the question, when is sine less than 0? Sine is less than 0 in those two quadrants, right? And when is cosine greater than 0? When is cosine positive? It's those two quadrants. So now we're looking at that theta that they give us in that last question to be terminating in the fourth quadrant. Is that something we can kind of visualize? All right. All right. That being said, let's get into some